Hello, and welcome to the Restful Stories. Let us begin our journey tonight by casting our gaze outward, far from the familiar comforts of our own world, into the cold, silent, and profound depths of interplanetary space. There, amidst the cosmic dark, hangs a world of serene and unparalleled beauty. A golden jewel adorned with a celestial crown. We will be spending our time with this magnificent giant tonight. And if you find yourself captivated by these journeys into the known and unknown, please do take a moment to subscribe, ensuring you will be notified whenever a new story is ready for you to explore. Our destination is, of course, Saturn, a name that resonates with myth, mystery, and the very limits of human discovery. For millennia, it was the final sentinel, the most distant traveler in the heavens, visible to the unaided eye, marking the boundary between the familiar planetary realm and the eternal, unchanging stars beyond. It was a god, a symbol of time and harvest, its slow 30-year journey across the zodiac, a measure of generations. But with the dawn of the telescopic age, this mythological figure began to transform into a place, a world of staggering complexity and physical laws, both familiar and profoundly alien. It became a destination for our curiosity, a puzzle box of rings, moons, and storms that challenged our understanding of how a world could be built. This is the story of that transformation, the story of Saturn as we have come to know it, a journey from a wandering star in the ancient night to a dynamic, living system of worlds revealed by the tireless eyes of our robotic explorers. In the grand celestial hierarchy of our solar system, Saturn holds a distinguished position as the second largest planet. A colossal world overshadowed only by the reigning monarch, Jupiter. This immense scale is difficult to fully comprehend from our terrestrial viewpoint. But if we were to place Saturn side by side with our own world, its sheer size would become immediately and humblingly apparent. For centuries, it was known only as a wandering star, a slow-moving point of light against the backdrop of the fixed constellations, its true nature hidden from the pre-telescopic world. It was not until the flourishing of optical science in the 17th century that humanity began to grasp the true dimensions of this distant giant. Through careful observation and the application of newly discovered laws of celestial mechanics, astronomers calculated its enormous girth. Its width is approximately 9.5 times that of Earth, a comparison that helps to frame its magnitude, but still falls short of conveying the reality. To visualize this more intuitively, imagine holding a common nickel in your hand, representing the planet we call home, a world of continents and oceans teeming with life. On this same scale, Saturn would loom before you as a great volleyball, a sphere so vast that it could contain our entire world many times over. The sheer volume of this giant is staggering, one could fit more than 760 Earths inside its colossal sphere, with room to spare. This single statistic paints a picture of a world built on a scale almost beyond human experience, a domain of immense atmospheric oceans and swirling continent-sized storms. Its gravitational influence is proportionally vast, a gentle but persistent shepherd for countless comets and asteroids, its presence subtly shaping the architecture of the entire outer solar system. Yet, this is where our understanding of Saturn must take a sharp and counterintuitive turn, for its story is one of profound paradoxes. For all its monumental size and overwhelming volume, Saturn is an entity of surprising lightness. It is, in fact, the least dense of all the 8 planets in our solar system, a characteristic so extreme that it gives rise to one of the most famous and delightful thought experiments in astronomy. If one could construct a bathtub of truly cosmic proportions, an ocean vast enough to hold worlds, and place all the planets within it, only one would bob to the surface. Saturn, the mighty giant, would float. This is because its average density is a mere 0.69 grams per cubic centimeter, a figure that is roughly 30% less than the density of liquid water. To put this in perspective, the rocky density of our own Earth is about 5.51 grams per cubic centimeter, making it nearly 8 times denser than Saturn. This extraordinary lack of density is the key to understanding its fundamental nature, revealing that its immense size is not composed of solid rock and metal, but of something far more ethereal. A vast conglomeration of the lightest elements in the universe. The secret to its improbable buoyancy, and indeed to its very structure, lies in its composition and the furious pace of its daily life. Saturn spins on its axis with breathtaking speed, a velocity that profoundly influences its very shape, transforming it from a simple sphere into a visibly flattened globe. This rapid rotation, combined with its gaseous, non-rigid structure, causes the planet to bulge significantly at its equator and compress at its poles. It is not a perfect sphere, but what astronomers call an oblate spheroid, a shape akin to a ball that has been gently squashed between 2 hands. This distortion is not a minor detail. It is the most pronounced of any planet in our solar system, a feature readily observable even through amateur telescopes on a clear night. The planet's polar diameter, the distance from its north pole to its south pole, is a mere 90% of its equatorial diameter, the vast waistline that circles its midsection. This 10% difference stretched across a body, some 120,000 kilometers, or roughly 75,000 miles, in diameter, is a visible testament to the relentless centrifugal forces generated by its dizzying spin. This profound flattening is not merely a geometric curiosity. It has direct and measurable consequences on the planet's gravitational field. the force of gravity at its bulging equator is noticeably weaker than at its compressed poles, measuring only about 74% of the polar gravity. An object's weight would literally change depending on its latitude on this dynamic world, becoming progressively lighter as it approached the equator, a direct result of being farther from the planet's center of mass and simultaneously being flung outward by its rapid rotation. All of these characteristics, its enormous size, its surprising lightness, its rapid spin, and its distorted shape, point to its classification as a gas giant. This term, first coined in the mid-20th century by the science fiction writer James Blish, and later adopted by the scientific community, perfectly encapsulates a world without a solid surface upon which to stand. To descend into Saturn would not be to land, but to fall endlessly through ever-deepening layers of atmosphere, a journey into a realm where the distinction between air and ocean blurs and disappears. There is no ground, no bedrock, only an increasingly dense and hot mixture of gases transitioning into strange liquid states deep within its mysterious core. The journey would begin in the cold, windy upper atmosphere, a region of ammonia ice clouds and turbulent jet streams, before plunging into layers of water ice and ammonium hydrosulfide. As the descent continues, the atmospheric pressure would mount relentlessly, compressing the surrounding gases until they cease to behave as gases at all. They would become a supercritical fluid, a strange state of matter that is neither liquid nor gas, a sea of unimaginable pressure and rising heat. This journey into the heart of Saturn is a voyage into a place where the familiar rules of our terrestrial world cease to apply, a domain defined by scale, speed, and a profound lack of solid ground. It is a world composed not of earth and stone, but of the primordial stuff of the cosmos, a true giant made of gas. And this primordial gas, the very substance from which Saturn is woven, is a near-perfect reflection of the universe in its infancy. The planet is composed primarily of hydrogen, the simplest and most abundant element, which accounts for an overwhelming 96% of its atmospheric mass. Floating within this vast hydrogen sea is a significant, though smaller, fraction of helium, making up another 3%. These two elements, forged in the first few minutes after the Big Bang, constitute the bulk of Saturn's being, a direct inheritance from the ancient solar nebula from which the Sun and all its planets were born. The remaining 1% is a subtle but crucial blend of other substances, trace amounts of cosmic dust and ices that add character and complexity to this gaseous world. Methane, ammonia, and water vapor are present in these upper layers, and it is these compounds, interacting with the faint but persistent sunlight, that are believed to create the planet's delicate and beautiful color palette, the soft yellows, the golden browns, and the creamy whites that streak its cloudy face in parallel bands. But to truly understand Saturn, we must continue our journey downward, past these visible cloud tops, into the crushing depths of its interior. As we descend, the pressure begins to build at a relentless, unimaginable rate. Kilometers turn into thousands of kilometers, and the gaseous hydrogen is compressed beyond anything we can experience on Earth. At a certain point, deep within the planet's interior, the immense weight of the overlying atmosphere performs an act of cosmic alchemy. It squeezes the hydrogen atoms so violently that their electrons are torn free from their protons, creating a bizarre and conductive state of matter known as metallic hydrogen. This is not a metal in the traditional sense, not a solid, gleaming substance like iron or gold. Instead, it is a fluid, an ocean of protons swimming in a sea of delocalized electrons. This exotic material behaves like a molten metal, capable of conducting electricity with great efficiency. It is within this vast, churning ocean of metallic hydrogen that the seeds of Saturn's powerful magnetic field are sown, a planetary-scale dynamo that dwarfs the magnetic field of our own world. Deeper still, our journey takes us toward the very heart of the giant. At the center of this swirling chaos of gas and metallic fluid, scientists believe lies a substantial core. Unlike the rest of the planet, this core is thought to be dense, a relic of the planet's formation. Models suggest it is composed of heavy metals like iron and nickel, the same elements that make up the core of our own planet. But it is likely surrounded by a thick mantle of rocky material and various ices that were able to solidify under the immense pressures. This solid heart, perhaps 10 to 20 times the mass of the entire Earth, serves as the gravitational anchor for the immense atmosphere that surrounds it. And it is a heart that burns with a furious, ancient heat. The temperature at the core of Saturn is estimated to reach around 11,700 degrees Celsius, which is nearly 21,100 degrees Fahrenheit. This is a temperature so extreme that it rivals the surface of the sun, a blistering inferno born from the residual heat of the planet's formation some 4.5 billion years ago, and continually supplemented by the slow gravitational contraction of the planet itself. This internal furnace is the engine that drives Saturn's dynamic weather, fueling the colossal storms that erupt in its atmosphere and causing the planet to radiate more than twice the energy into space than it receives from the distant sun. This whole immense and complex structure, from the icy cloud tops to the fiery core, spins with a dizzying velocity. A day on Saturn, the time it takes to complete one full rotation on its axis, is a mere 10.7 hours long. This furious pace of rotation, the second shortest of any planet in the solar system after Jupiter, is the very engine that drives the equatorial bulge and polar flattening we spoke of earlier, stretching the planet's waistline and giving it its distinctive oblate shape. This frantic daily spin stands in stark and dramatic contrast to the planet's long, leisurely journey through the cosmos. A single year on Saturn, the time it takes for it to complete one full orbit around the Sun, is equivalent to a staggering 29.4 Earth years. For a human being, a lifetime would encompass only 2 or 3 of these grand Saturnian circuits. This stately procession is a direct consequence of the planet's immense distance from the Sun, a vast gulf of space that separates it from the inner solar system. Saturn orbits our star at an average distance of about 1.4 billion kilometers, which is approximately 886 million miles. From this remote vantage point, the Sun appears not as a great, warming disk in the sky, but as a small, intensely brilliant star. Its light and heat greatly diminished by the vast expanse it must cross. It takes sunlight a full 80 minutes to complete this journey, to travel from the Sun's fiery surface to the reflective cloud tops of Saturn. The light that illuminates this distant world is, in a very real sense, ancient history by the time it arrives. An 80-minute-old message from a star that is nearly 1 billion miles away. Yet this slow, majestic orbit is not a simple, flat circle. Saturn's axis is tilted by 26.73 degrees relative to its orbital plane. This tilt is remarkably similar to Earth's own 23.5 degree inclination, and it means that Saturn, like our own world, experiences distinct seasons. But these are seasons of an entirely different magnitude. Each one, spring, summer, autumn, winter, lasts for more than 7 Earth years, a slow, subtle unfolding of celestial change. As Saturn proceeds on its long path, its tilt causes first one hemisphere, then the other, to be more directly exposed to the Sun's faint rays. This tilt is also responsible for the magnificent and ever-changing views we get of the planet's most spectacular and defining attribute, a celestial crown that has captivated humanity since the dawn of telescopic observation. Its rings, the most famous and extensive in the entire solar system. This celestial crown, a shimmering halo that distinguishes Saturn from all other worlds, was a source of profound mystery to its earliest observers. When Galileo Galilei first turned his primitive telescope toward the planet in 1610, he saw not a ring, but what he described as handles or arms, 2 smaller bodies flanking the main sphere. For decades, the true nature of this feature remained elusive, a puzzle that shifted and changed with the quality of the available optics. It was not until 1655, when the Dutch astronomer Christiaan Huygens used a more powerful telescope, that the proposal was made that Saturn was encircled by a thin, flat ring that touched it nowhere. This was a revolutionary idea, but even it could not prepare the world for the breathtaking complexity that later observations would reveal. We now know that the rings are not solid, unified objects at all. Instead, they are a vast, sprawling disk made up of countless billions of individual particles of ice, dust, and rock, each one in its own independent orbit around the planet, like a tiny, personal moon. The vast majority of this material is water ice, brilliantly white and highly reflective, which is why the rings shine so brightly in the sunlight, even from a distance of over 1 billion kilometers. These orbiting particles come in a spectacular range of sizes, creating a diverse and dynamic population within the ring plane. Some are as fine as a grain of sand or a mote of dust, while others are the size of pebbles or small stones. Larger still are chunks the size of a car, and the largest among them are veritable icebergs, mountain-sized blocks of frozen water that drift silently through the cosmic blizzard, some reaching the dimensions of a multi-story house. The sheer scale of this structure is almost beyond earthly comparison. The main rings stretch out for more than 282,000 kilometers, or about 175,000 miles, from end to end, a distance so vast it could nearly bridge the gap between the Earth and our moon. Yet for all their incredible breadth, the rings are almost impossibly thin. This is perhaps their most astonishing and paradoxical quality. The main rings are typically only about 9 meters, or roughly 30 feet, thick. To put this into perspective, if you were to build a scale model of the rings that was 1 kilometer wide, it would be thinner than a single sheet of paper. This extreme thinness means that when the rings are viewed edge-on from Earth, a phenomenon that occurs roughly every 15 years as Saturn orbits the Sun, they all but disappear, visible only as a faint, thin line of light, even in the most powerful telescopes. This vast, impossibly thin plane is not a single entity, but a complex system of many individual rings and gaps, each with its own unique character. They are named alphabetically, but not in a simple outward progression. Instead, the letters were assigned in the order of their discovery, a testament to the slow, piecemeal way in which their structure was revealed to humanity over the centuries. The main rings, visible from Earth, are the C, B, and A rings. The B ring is the broadest, brightest, and most massive of them all, while the C ring, closer to the planet, is fainter and more transparent. Farthest out of this main group is the A ring. Beyond these are the much fainter rings, the D ring, which is the innermost and almost phantom-like in its tenuity, and the F, G, and E rings, which lie outside the main system. Woven into this intricate tapestry are gaps and divisions, regions where the density of ring particles drops off sharply. The most prominent and famous of these is the Cassini division, a dark gap some 4,800 kilometers, or 3,000 miles, wide that separates the bright B ring from the A ring. This feature was first observed in 1675 by the Italian-French astronomer Giovanni Domenico Cassini, who made many pioneering discoveries about Saturn and its moons. For a long time, it was thought that such gaps were completely empty, but we now know they are simply regions with far less material. Their particles cleared out by complex gravitational interactions. This raises a crucial question. What holds this delicate, intricate system together? How do the rings maintain their sharp edges and a structure as fine as the grooves on a phonograph record? The answer lies in the subtle gravitational influence of some of Saturn's many moons. A number of small moons, now known as shepherd moons, orbit near the edges of the rings or within the gaps themselves. Their gravity acts like a pair of invisible hands, herding the straying ring particles back into line, preventing them from spreading out and dissipating into space. Prometheus and Pandora, for instance, patrol the inner and outer edges of the slender F ring, their combined gravitational nudges keeping its particles confined to a narrow, well-defined band. This constant gravitational dance between moon and particle is what gives the rings their enduring structure. And this structure is even more complex than it appears. The rings have their own atmosphere, a cosmic phantom born from the very substance of the rings themselves. It is an incredibly thin, tenuous envelope of molecular oxygen, so sparse that it would be considered a hard vacuum by any terrestrial standard. Scientists believe it is formed when ultraviolet light from the sun and impacts from micrometeoroids bombard the water ice of the ring particles, splitting the water molecules and releasing oxygen. This discovery, made by the Cassini spacecraft, added yet another layer of wonder to this already fascinating system. The ultimate question, of course, is where did this magnificent structure come from? For a long time, it was assumed the rings were primordial, formed at the same time as Saturn itself 4.5 billion years ago. But recent evidence suggests a much more dramatic and recent origin. Their icy brilliance is a key clue. If they were truly ancient, they should have been darkened over billions of years by accumulating cosmic dust. Scientists now believe the rings may be the glittering debris from a catastrophic event, perhaps the shattered remains of a large moon, a passing comet, or an asteroid that strayed too close to Saturn and was torn apart by the planet's immense tidal forces. This cataclysm may have happened relatively recently in cosmic terms. The rings could be young, possibly only a few 100 million years old, meaning they may have formed while dinosaurs still walked the Earth, a fleeting and temporary jewel in the crown of the solar system. This fleeting and temporary nature, a cosmic memento mori, is not just a theoretical possibility. It is an active and ongoing process. The beautiful jewel is indeed dissolving. Scientists have confirmed that the rings are disappearing, their icy particles being pulled inexorably inward by Saturn's immense gravity and magnetic field in a phenomenon poetically dubbed ring rain. This is not a gentle shower, but a constant planetary scale deluge of charged water particles funneled along magnetic field lines that fall into the planet's upper atmosphere, altering its chemistry and composition. The rate of this decay is a subject of intense study, but some predictions suggest the entire ring system could be gone in as little as 100 million years, with the most generous estimates giving them perhaps 300 million years at most. In the grand timeline of the solar system, this is but a fleeting moment, and we are living in a privileged age, a brief window of cosmic time where we are able to witness Saturn in its full, glorious, and ephemeral splendor. This slow demise is intrinsically linked to the complex internal dynamics of the rings themselves. They are not a solid platter spinning as one. Instead, they are a comic ballet of incomprehensible scale, where each individual particle, from the tiniest speck of dust to the largest house-sized iceberg, follows its own orbital path, obeying the precise laws of gravity first laid down by Johannes Kepler in the 17th century. The innermost particles, closer to Saturn's immense gravitational pull, race around the planet far more quickly than their counterparts on the outer edges. This differential rotation creates a state of constant shear and collision, a cosmic traffic jam where the inner lanes move at blistering speeds, while the outer lanes proceed at a more stately pace. This perpetual motion, this grinding of cosmic gears, is what helps to shape the rings, but it also contributes to their instability, allowing gravitational and magnetic forces to peel particles away and draw them down into the planet's embrace. But the story of Saturn's rings extends far beyond what is visible to the naked eye, or even to standard optical telescopes. Surrounding the familiar bright system is an invisible ring, a ghostly halo of such vast proportions that it dwarfs the main rings entirely. Discovered by the Cassini spacecraft using its infrared instruments, this enormous, tenuous ring is believed to be made of dark, dusty particles originating from one of Saturn's most distant and peculiar moons, Phoebe. This halo ring is tilted relative to the main ring plane and is incredibly thick, its dimensions measured in millions of kilometers. The dark material that populates this ghostly structure is thought to be blasted off the surface of Phoebe by a constant bombardment of micrometeoroids. This debris then spirals slowly inward toward Saturn, and on its journey, it encounters another of Saturn's moons, the strange world of Iapetus. The dark dust from the Phoebe ring coats one entire hemisphere of Iapetus, painting it as black as coal, and creating the moon's distinctive two-toned appearance, a celestial yin and yang that baffled astronomers for centuries. Back within the main system, nestled between the A and B rings, lies another marvel of celestial mechanics, the F ring. This is one of the most active and perplexing features in the entire solar system. Far from being a uniform band of particles, the F ring has a curious and ever-changing braided appearance, a complex structure of knots, clumps, and intertwined strands that can form and dissipate over the course of mere hours. Its bizarre behavior is orchestrated by the gravitational tug of war between its two tiny shepherd moons, Prometheus and Pandora, whose chaotic orbits weave in and out, twisting the delicate ring material like a skein of cosmic yarn. This intricate dance of rings and shepherd moons is just a small part of a much larger and more complex retinue. Saturn presides over a vast and complex family of 274 known moons and smaller moonlets, a collection so numerous and diverse that it constitutes a miniature solar system in its own right. This lunar court is a menagerie of strange and wonderful worlds, from tiny, irregularly shaped rocks captured from the asteroid belt to colossal spheres with their own atmospheres and weather. And reigning over them all is the undisputed monarch of the Saturnian system, the giant moon Titan. Titan is Saturn's largest moon, a world so immense that it is the second largest satellite in our entire solar system, surpassed only by Jupiter's moon Ganymede. To truly appreciate its scale, one must understand that this colossal moon is a world so large that it surpasses the planet Mercury in size. If it were orbiting the Sun on its own, it would undoubtedly be classified as a planet. But Titan's size is not its most remarkable feature. What truly sets it apart is its atmosphere, a thick, hazy, orange shroud that is far denser than Earth's own. This atmosphere is rich in nitrogen, the same primary gas we breathe, but it is laced with a complex soup of organic molecules like methane and ethane. This thick veil completely obscures the surface, making Titan a world of mystery for centuries. It was not until the arrival of the Cassini spacecraft and its Huygens probe, which made a historic descent to the surface in 2005, that the secrets hidden beneath the orange haze were finally revealed. Huygens landed on a surface that was startlingly familiar, yet profoundly alien. It found a landscape carved by liquid, with river channels, shorelines, and vast plains. But on Titan, where surface temperatures hover around minus 179 degrees Celsius, or about minus 290 degrees Fahrenheit, water is as hard as rock. The liquid that flows in its rivers and fills its great lakes and seas, some as large as the Great Lakes of North America, is not water, but liquid methane and ethane. Titan possesses a weather cycle analogous to Earth's water cycle, with methane rain falling from hydrocarbon clouds to feed the rivers that flow into the vast, still seas. And while Titan presents a cold, alien analog to our own world, another of Saturn's moons offers a far more dynamic and tantalizing spectacle. Enceladus, a much smaller moon, appears at first glance to be a simple, placid ball of brilliant white ice, one of the most reflective objects in the solar system. But lurking beneath this serene facade is a world of incredible geological activity. In 2005, the Cassini spacecraft made a stunning discovery, observing enormous plumes of water vapor and ice particles erupting from a series of long, parallel cracks in the Moon's southern polar region, features that have been nicknamed tiger stripes. Enceladus, it turned out, was a world of ice volcanism, or cryovolcanism. These spectacular geysers spew a mixture of water, salts, and simple organic compounds hundreds of kilometers, hundreds of miles, out into the cold vacuum of space, forming a tenuous plume that actually contributes material to Saturn's faint E-ring. This discovery was a watershed moment in planetary science, for it provided powerful evidence that beneath its frozen crust, Enceladus harbors a vast, global ocean of liquid water, kept warm by tidal forces generated by Saturn's immense gravity. A subterranean ocean filled with water and organic molecules and warmed by an internal heat source contains all the ingredients that scientists believe are necessary for life to arise, making this small, icy moon one of the most compelling places in the solar system to search for extraterrestrial organisms. The tantalizing prospect of a subsurface ocean, a hidden cradle of potential life, elevates Enceladus from a mere curiosity to a prime target in our search for biology beyond Earth. The implications are profound. For centuries, the search for life has been largely confined to the so-called habitable zone, that narrow band around a star where temperatures are just right for liquid water to exist on a planet's surface. But Enceladus demonstrates that the conditions for life might exist far from this zone, in the cold, dark depths of the outer solar system, powered not by the gentle warmth of a distant sun, but by the relentless gravitational squeezing and stretching of a giant planet. This tidal heating, a constant kneading of the moon's interior, generates enough friction and energy to maintain a liquid ocean beneath an icy shell tens of kilometers thick. The geysers of the South Pole are, in effect, a direct line of evidence, a sampling of this hidden ocean's contents being vented into space. The Cassini spacecraft, in its daring flybys, was able to taste these plumes, its instruments detecting not just water and salt, but also a brew of simple organic compounds like methane and even more complex molecules, the very building blocks of life as we know it. The presence of these ingredients, combined with evidence of hydrothermal activity on the ocean floor, analogous to the deep sea vents on Earth where life thrives in the absence of sunlight, makes the ocean of Enceladus arguably the most accessible and promising extraterrestrial habitat in our solar system. The discovery has shifted our understanding of where life might be found and has fueled a new generation of mission concepts designed to return to this tiny moon, to fly through its plumes again with more advanced instruments, and perhaps one day to land on its surface and drill through the ice to the dark, mysterious ocean below. While Enceladus whispers of hidden oceans and the potential for life, another of Saturn's moons, Iapetus, presents a stark and beautiful mystery of a completely different kind. Iapetus is a world of dramatic and absolute contrasts, a celestial body with a distinctive two-toned coloration that has puzzled astronomers since its discovery by Giovanni Cassini in the late 17th century. One entire hemisphere, its leading side as it orbits Saturn, is as dark as freshly laid asphalt, reflecting almost no light. The other hemisphere, its trailing side, is as bright and brilliant as freshly fallen snow. This stark dichotomy, a perfect hemispheric split between light and dark, is unique in the solar system. The dividing line between the two regions is not a gradual fading, but a relatively sharp and complex boundary. For centuries, the cause of this strange appearance was a subject of intense speculation. Was the dark material erupting from the moon's interior? Was it being painted by some external force? The answer, it seems, lies in a combination of factors, a story that connects this moon to the far-flung, invisible ring we encountered earlier. The leading theory, now strongly supported by data from the Cassini mission, is that the dark material is indeed external, a cosmic dust that originates from Saturn's vast and tenuous Phoebe ring. As Iapetus plows through this faint, dark halo on its orbital journey, its leading face collects a thin veneer of this dusty material, much like a car's windshield accumulates insects on a long drive. This dark coating, however, is only the beginning of the story. Because the dark material absorbs more sunlight than the bright ice, it heats up. This slight increase in temperature is just enough to cause any ice in the darkened region to sublimate, to turn directly from a solid into a gas. This water vapor then migrates across the moon's surface, eventually refreezing and depositing as bright, clean frost on the colder, trailing hemisphere, a process of thermal segregation that over millions of years has amplified the initial contrast, making the dark side darker and the bright side brighter, creating the stark, beautiful dichotomy we see today. The rogues gallery of Saturn's moons continues with Mimas, a small inner satellite that bears an uncanny and purely coincidental resemblance to a famous icon of science fiction. The moon is dominated by a single enormous impact crater named Herschel, after the moon's discoverer, William Herschel. This colossal crater is 130 kilometers, or about 81 miles, in diameter, a full 1/3 of the diameter of the moon itself. The impact that created it must have been so powerful that it came perilously close to shattering Mimas completely. At the center of the crater is a massive central peak, rising some 6 kilometers, or nearly 4 miles, from the crater floor, a testament to the immense forces that were unleashed in the cataclysmic event. This combination of a relatively small, spherical moon and a single, oversized crater gives Mimas the unmistakable appearance of the Death Star from the Star Wars films, a pop culture comparison that has become inextricably linked with the moon's identity. Further in toward the planet, nestled within the complex ring system, are a pair of moons whose shapes defy the typical spherical form we associate with celestial bodies. Pan and Atlas, two of the small shepherd moons, are shaped not like balls, but like flying saucers. They are distinguished by a prominent, thin, equatorial ridge that encircles their entire circumference. This bizarre feature is believed to have been formed by the slow accretion of ring particles onto the moon's equators. As these tiny moons orbit within the rings, their gravity gently sweeps up material from the ring plane, which then accumulates around their middles, building up over eons into the strange, skirt-like ridges we see today. They are worlds that have literally been shaped by their environment, sculpted by the very rings they help to maintain. Even farther out, beyond the main rings, but still well within Saturn's gravitational grasp, is Rhea, the second largest of Saturn's moons. This heavily cratered, icy world was long thought to be a relatively simple and inactive body, a geologically dead relic from the early solar system. But observations from the Cassini spacecraft hinted at something extraordinary. In 2008, scientists announced that they had detected evidence suggesting that Rhea may have a tenuous ring system of its own, a faint, wispy halo of debris in orbit around the moon. This was a startling and unprecedented discovery. If confirmed, it would make Rhea the first moon known to possess its own rings, a moon with its own miniature version of its parent planet's most famous feature. The evidence came from the behavior of electrons trapped in Saturn's magnetic field as Cassini flew past Rhea. The data showed a pattern that suggested something was absorbing these electrons, and a system of rings was the most plausible explanation. While subsequent observations have not yet definitively confirmed the existence of these rings, the possibility remains a tantalizing one, a hint that the complex dynamics that shape planetary rings may also operate on a much smaller scale around their moons. This ever-expanding cast of characters, from the water-spouting Enceladus to the two-faced Iapetus, from the Death Star Mimas to the potentially ringed Rhea, is given a sense of order and tradition through the naming conventions established by the International Astronomical Union. Many of Saturn's moons, particularly the larger ones discovered in earlier centuries, are named after the Titans, the powerful deities of Greek mythology who were the siblings of Cronus, the Greek equivalent of the Roman god Saturn. This mythological theme provides a poetic and epic backdrop to the scientific exploration of this vast and complex system, a family of worlds with names like Tethys, Dione, and Hyperion, each one a unique character in the grand celestial drama unfolding around the ringed planet. And this drama extends far beyond the larger, more famous players. The system is teeming with smaller bodies, with 131 of Saturn's known moons being less than 50 kilometers, or about 31 miles, in diameter. Many of these are likely captured asteroids or comets, irregular chunks of rock and ice that strayed too close and were snared by Saturn's gravity. Some of these tiny inner moons, particularly those orbiting within or near the rings, are locked in a state of perpetual creation and destruction, a cosmic dance of collision and reassembly. Fragments are constantly being chipped off, and sometimes entire small moons can be shattered by impacts, their debris temporarily forming a new, tiny ring, which over time can coalesce and accrete to form a new moon, a cycle of cosmic birth, death, and rebirth playing out in the gravitational crucible of the ring system. And just as the moons and rings are a realm of constant change and dynamic activity, so too is the colossal planet that governs them all. Saturn's upper atmosphere is a vast and turbulent ocean of clouds, a canvas of subtle colors and furious winds. This atmosphere is not a uniform, placid envelope, but is divided into distinct bands of clouds that run parallel to the equator, a visible manifestation of the planet's incredibly powerful jet streams. These bands, alternating in color and texture, are a hallmark of the gas giants, a direct result of their rapid rotation and the heat bubbling up from their deep interiors. These bands of clouds, the visible skin of the giant planet, are a complex, multi-layered affair, a meteorological tapestry woven from exotic ices. The highest, most visible layers, the ones that give Saturn its characteristic pale, butterscotch hue, are composed of crystals of frozen ammonia. This ammonia ice condenses out of the upwelling gases in the frigid upper atmosphere, where temperatures can plummet to below minus 173 degrees Celsius, or about minus 280 degrees Fahrenheit. These clouds of ammonia cirrus are what we see when we look at the planet through a telescope. Their subtle variations in thickness and altitude creating the soft, banded pattern. But this is only the top of the weather layer. Below these wispy, high-altitude clouds lies another, deeper deck, a layer where temperatures are slightly warmer and pressures are higher. Here, it is believed that clouds of ammonium hydrosulfide ice form, a compound that is unstable on Earth, but can exist in the unique chemical environment of a gas giant. These clouds are likely responsible for some of the darker, brownish colors that can sometimes be seen in the deeper troughs between the brighter bands. And deeper still, in a region of the atmosphere that is perpetually hidden from our direct view, lies a third layer of clouds, one composed of something far more familiar to us: water ice. In this lower, warmer region, water vapor rising from the planet's deep interior finally condenses, forming a vast, planet-encircling layer of water clouds, perhaps punctuated by colossal thunderstorms that dwarf anything seen on Earth. This three-tiered cloud structure, ammonia ice on top, ammonium hydrosulfide in the middle, and water ice at the bottom, is the fundamental framework of Saturn's atmosphere. The stunning visual pattern of the planet, the alternating yellow and gold bands that encircle its globe, is the direct result of a titanic struggle between two powerful forces. On the one hand, there is the internal heat of the planet, the fiery furnace of its core that constantly radiates warmth outward. This heat drives powerful convective currents, causing vast parcels of gas to rise from the deep interior, cool as they reach the upper atmosphere, and then sink back down again. A process not unlike the bubbling of a giant pot of cosmic soup. On the other hand, there is the planet's dizzyingly rapid rotation, the 10.7-hour day that spins the entire colossal structure at incredible speeds. This rapid spin deflects the simple up and down motion of the convection currents, stretching them sideways, parallel to the equator, into the planet-wide jet streams we see as the bands. The brighter bands, known as zones, are regions of upwelling gas, where the ammonia clouds are higher and thicker. The darker bands, known as belts, are regions where the gas is sinking, allowing us to peer slightly deeper into the atmosphere, where the darker ammonium hydrosulfide clouds are thought to reside. It is the combination of this internal heat and rapid rotation that paints the planet with its distinctive stripes. The speeds of these atmospheric flows are almost beyond comprehension. The winds around Saturn's equator are among the fastest in the entire solar system, reaching terrifying speeds of up to 1,800 kilometers per hour, which is roughly 1,100 miles per hour. This is more than 4 times faster than the strongest hurricane force winds ever recorded on Earth, a perpetual, planet-girdling jet stream of unimaginable power. These winds are not just confined to the equator. The entire atmosphere is sheared into a series of alternating east-west jets, a testament to the immense rotational energy that is pumped into the planet's weather systems. Embedded within these powerful zonal winds are storms, colossal atmospheric disturbances that can grow to the size of continents and last for months or even years. Saturn has its own versions of Jupiter's famous Great Red Spot, vast, oval-shaped storms that are essentially giant anticyclonic vortices, high-pressure systems that spin in the opposite direction to the planet's rotation. These storms can appear as white or brown ovals, churning through the cloud tops and interacting with the surrounding jet streams. Periodically, the planet experiences truly monstrous storms, known as Great White Spots, which are so large they can encircle the entire planet. These planet-girdling tempests seem to erupt roughly once every Saturnian year, or about every 30 Earth years, and are thought to be caused by a massive upwelling of moist air from the deep water cloud layer, a kind of planetary scale super thunderstorm that unleashes its energy into the upper atmosphere. The most recent of these appeared in 2010 and was studied in incredible detail by the Cassini spacecraft, providing unprecedented insights into the deep atmospheric dynamics of the gas giant. But perhaps the single most bizarre and enigmatic weather feature in the entire solar system is found at Saturn's North Pole. Encircling the pole is a massive, hexagonal-shaped jet stream, a six-sided weather pattern of breathtaking geometric perfection. Each side of the hexagon is wider than the diameter of the Earth, and the winds within this structure rage at over 322 kilometers per hour, or about 200 miles per hour. This feature is not a fleeting storm. It is a stable, long-lived structure, having been observed by the Voyager spacecraft in the early 1980s and seen in detail by Cassini more than 2 decades later. Nothing like it has ever been seen on any other planet. Its origin is a profound mystery that continues to fascinate and perplex scientists. It appears to be a standing wave, a pattern that is somehow anchored to the planet's deep rotation, but the precise mechanism that forces a jet stream into such a stark and unwavering hexagonal shape is still unknown. It is a stunning example of the complex and often counterintuitive fluid dynamics that can emerge on a rapidly rotating gas giant. A piece of natural geometry on a planetary scale. And as if one polar mystery were not enough, Saturn's South Pole presents another, equally compelling vortex. Over the South Pole, a swirling, hurricane-like storm is permanently fixed, its eye clear, and its walls towering high into the atmosphere. This southern vortex has all the hallmarks of a terrestrial hurricane, but on a scale that dwarfs any storm on Earth. It is locked to the pole, a permanent fixture of the planet's circulation, with wind speeds at its edge reaching up to 550 kilometers per hour, or about 340 miles per hour. The eye of this polar hurricane is some 2,000 kilometers, or about 1,200 miles, across, and it is surrounded by a towering wall of clouds that rises tens of kilometers higher than the surrounding atmosphere. This southern storm, combined with the northern hexagon, paints a picture of a planet with a profoundly strange and complex atmospheric personality. A world where the poles are home to some of the most extreme and bizarre weather phenomena imaginable. And the atmospheric drama is not confined to the visible layers. High above the cloud tops, in the tenuous upper reaches of the planet's atmosphere, Saturn experiences its own version of the northern and southern lights. Just like on Earth, the planet's powerful magnetic field funnels charged particles from the solar wind toward the poles, where they collide with atmospheric gases and cause them to glow. These Saturnian auroras are vast, shimmering curtains of light that are centered on the planet's poles, but they are far more powerful and extensive than their terrestrial counterparts. While they can sometimes be seen invisible light. These auroras are mainly visible in the ultraviolet spectrum, a light that is invisible to the human eye. They are a constant, flickering crown of ethereal light, a beautiful and silent testament to the powerful and complex interaction between the planet, its magnetic field, and the constant stream of particles flowing outward from the sun. This ethereal light, a ghostly flicker in the ultraviolet, is a modern discovery, a secret of the planet revealed only in the space age. Yet Saturn itself has been a steadfast and familiar character in the human drama since the dawn of history. It holds the distinction of being the most distant planet that can be readily seen from Earth with the naked eye, a serene, yellowish point of light journeying slowly across the celestial sphere. In the grand theater of the night sky, it is the fifth brightest object, outshone only by the Sun, the Moon, Venus, and Jupiter. This steady, reliable brightness made it a cornerstone of ancient astronomy, a celestial marker used by cultures all over the world to track the passage of time and the changing of the seasons. Its slow, deliberate movement against the backdrop of the fixed stars gave it an aura of wisdom and authority. The ancient Assyrians, keen observers of the heavens, nicknamed it Lubadsagush, a name that translates to oldest of the old, a fitting tribute to its stately, almost glacial pace across the zodiac. For these early skywatchers, Saturn took nearly 30 years to complete its circuit, its long journey embodying a sense of cosmic patience and endurance. It was a celestial elder, a stark contrast to the fleet-footed Mercury or the brilliant, wandering Venus. This association with age, time, and deliberation carried over into the mythologies of the classical world. The planet is named for the Roman god of agriculture, Saturnus, a deity who presided over harvests, wealth, and the passage of time, often associated with a golden age of peace and abundance. The famous Roman festival of Saturnalia, a time of feasting, gift-giving, and the temporary subversion of social norms, was held in his honor during the winter solstice, a celebration of the eventual return of light and life. This Roman deity was a direct inheritor of an even more ancient tradition. In Greek mythology, the planet was known as Cronus, one of the original Titans and the father of the Olympian gods. Cronus was the god of time, and his story was one of power, rebellion, and the inexorable march of generations. A grand, mythological narrative that found its celestial embodiment in the slow, majestic orbit of the most distant of the known planets. For millennia, this was the extent of human knowledge, a bright, slow-moving star, wrapped in myth and imbued with deep cultural significance. It marked the very edge of the known cosmos, the final, outermost sentinel of the planetary system. Beyond it lay only the unchanging, eternal realm of the fixed stars. This ancient and enduring worldview was shattered in the early 17th century by a single man and his revolutionary new instrument. In 1610, the Italian astronomer Galileo Galilei turned his recently constructed telescope toward the heavens. And in doing so, he forever changed our understanding of the universe. When he pointed his small, crude instrument at Saturn, he saw something that no human had ever seen before. The planet was not a simple, solitary point of light. It appeared to have companions, what he first described as handles or arms, two smaller, fainter bodies that seemed to be attached to either side of the planet's globe. His telescope was not powerful enough to resolve their true nature, and he was deeply perplexed by what he saw. He observed them for months, noting that they did not orbit the planet in the same way that the moons he had discovered around Jupiter did. To add to the mystery, when he observed Saturn again a couple of years later, these strange appendages had vanished entirely, an observation that left him utterly baffled. What he was seeing, of course, was the planet's magnificent ring system, but his instrument lacked the optical power to distinguish it as a separate, disc-like structure. He was seeing the extended onsoi, the east and west extremities of the rings, and his later, confusing observation occurred at a time when the rings were tilted edge onto the Earth, making them effectively invisible to his telescope. The puzzle of Saturn's strange appearance would persist for nearly half a century, a tantalizing mystery at the limits of scientific observation. The next great leap in understanding came from the Dutch astronomer Christian Huygens. Armed with a vastly superior telescope of his own design, one that was far more powerful than Galileo's, Huygens was able to see the planet with unprecedented clarity. In 1655, after careful and systematic observation, he solved the riddle that had vexed Galileo. He proposed that Saturn was surrounded by a thin, flat ring that was not attached to the planet at all. A solid, continuous structure that encircled it without touching it. This was a bold and brilliant deduction, one that perfectly explained why the planet's appearance changed over time. The changing aspect of the ring as both Saturn and Earth moved in their orbits accounted for the periodic disappearance of the handles. Huygens's discovery transformed Saturn from a planetary anomaly into a celestial wonder, a world adorned with a feature unique in the known universe. With this new, more accurate model, the modern era of Saturnian exploration had begun, a journey that would be carried out over the succeeding centuries by generations of astronomers, each armed with progressively more powerful telescopes, slowly and painstakingly revealing the intricate details of the rings and the ever-growing family of moons. But for all the power of ground-based observation, our understanding of this distant world was destined to remain incomplete. To truly know Saturn, we had to go there. That journey began in the latter half of the 20th century, with the dawn of the space age. 4 robotic emissaries from Earth have, to date, made the long and arduous journey across the solar system to visit the ringed planet, each one built upon the knowledge of its predecessors, peeling back the layers of mystery and revealing a world of unimaginable complexity and beauty. The first of these intrepid explorers was Pioneer 11. Launched in 1973, this small, rugged spacecraft was part of a trailblazing mission to the outer solar system. After a successful flyby of Jupiter, its trajectory was altered to send it on a daring, first-ever encounter with Saturn. In September 1979, after a journey of more than 6 years, Pioneer 11 flew through the Saturn system, passing just 21,000 kilometers, or about 13,000 miles, above the planet's cloud tops. It was a risky maneuver, sending the probe on a path that took it between the planet and its rings. The spacecraft's instruments provided the first close-up measurements of the planet's magnetic field and radiation belts, and it discovered a new, faint ring, which we now call the F ring. Its images, though low in resolution by modern standards, were our first intimate portraits of this distant giant, confirming its banded atmosphere and providing a new perspective on the rings. Pioneer 11 was a pathfinder, a bold reconnaissance mission that paved the way for the far more sophisticated missions that would follow in its wake. It was the first human artifact to gaze upon the majestic world of Saturn from close range, a robotic Vasco da Gama charting a new ocean of cosmic discovery. Pioneer 11's fleeting, historic glimpse was but a prelude, a tantalizing appetizer for the main course of exploration that was to follow. The true golden age of Saturnian discovery began with the arrival of the twin Voyager spacecraft, two of the most ambitious and scientifically productive missions ever dispatched from our world. Voyager 1 and Voyager 2, launched within weeks of each other in 1977, took advantage of a rare celestial alignment that allowed them to perform a grand tour of the outer planets, using the gravity of each giant planet to slingshot them onward to the next. After their own spectacular encounters with Jupiter, they set their sights on Saturn. Voyager 1 arrived first in November 1980, followed by its sibling, Voyager 2, in August 1981. These were not mere flybys. They were comprehensive surveys, their advanced cameras and instruments revealing the Saturn system in breathtaking, unprecedented detail. The blurry, indistinct images from Pioneer were replaced with a stunning gallery of sharp, vibrant portraits, showcasing the intricate cloud patterns, the subtle coloration of the atmospheric bands, and the almost unbelievable complexity of the rings. It was the Voyagers that first revealed the rings to be composed of thousands of individual ringlets and gaps, a structure far more complex than the simple concentric bands imagined by Huygens. They discovered the strange, braided nature of the F ring, and were the first to spot the mysterious, ghostly spokes, dark, radial features that seemed to form and dissipate within the B ring over the course of a few hours, defying any easy explanation. The voyagers also turned their keen eyes on the moons, transforming them from simple points of light into unique, individual worlds. They gave us our first close-up views of the cratered face of Mimas, the bizarre, two-toned surface of Iapetus, and the geologically active terrain of Enceladus, hinting for the first time at the dynamic processes that were shaping these icy satellites. It was Voyager 1 that provided the first detailed reconnaissance of the giant moon, Titan, revealing its thick, impenetrable orange haze and confirming the presence of a dense, nitrogen-rich atmosphere. A discovery that electrified the scientific community and marked Titan as a world of profound astrobiological interest. The Voyager encounters were a quantum leap in our understanding, a deluge of data that would keep planetary scientists busy for decades, rewriting the textbooks and setting the stage for the next, even more ambitious chapter in our exploration of Saturn. That next chapter was the Cassini-Huygens mission, a joint project of NASA, the European Space Agency, and the Italian Space Agency, and arguably the most sophisticated and successful flagship mission in the history of planetary exploration. Launched in 1997, the Cassini spacecraft was a behemoth, the size of a small school bus and packed with an incredibly powerful and diverse suite of 12 scientific instruments. It also carried a passenger, the Huygens probe, a disc-shaped lander designed to make a historic descent through Titan's atmosphere and land on its mysterious surface. After a 7-year journey across the solar system, the Cassini-Huygens duo arrived at Saturn in July 2004. But unlike its predecessors, Cassini was not destined for a fleeting flyby. It fired its main engine and gracefully entered into orbit around the ringed planet, becoming Saturn's first, and to date, only artificial moon. For the next 13 years, Cassini would be our robotic eyes, ears, and hands in the Saturn system, conducting an exhaustive, in-depth tour that would revolutionize our understanding of this complex and dynamic world. The mission was a masterpiece of celestial mechanics and scientific planning, completing hundreds of orbits, each one carefully designed to study a different aspect of the planet, its rings, its magnetic field, and its vast family of moons. Cassini's cameras sent back hundreds of thousands of images, each one more stunning and revealing than the last, from breathtaking panoramic vistas of the rings to intimate, high-resolution portraits of the moon's surfaces. One of the mission's earliest and most dramatic highlights came in January 2005, when the Huygens probe was released from the mothership to begin its fateful, one-way journey to Titan. After a 2.5-hour descent through the thick, orange clouds suspended beneath its parachute, the probe made a successful, soft landing on a solid, albeit frigid, surface. During its descent, and for a short time after landing, Huygens transmitted a priceless stream of data and images, giving humanity its first and only direct ground-level view of this alien world. It revealed a landscape eerily reminiscent of Earth, with drainage channels, riverbeds, and rounded stones that were in fact chunks of solid water ice, all sculpted by the flow of liquid methane. It was a landmark achievement, the most distant landing ever accomplished by a human-made object, a triumph of engineering, and a moment of profound discovery. The Huygens landing was just the beginning of Cassini's long and fruitful sojourn. The orbiter went on to make more than 100 targeted flybys of Titan, using its powerful radar instrument to pierce the hazy atmosphere and map the surface in detail. It was Cassini's radar that discovered the vast lakes and seas of liquid methane and ethane concentrated near Titan's poles, confirming that this moon possessed a liquid cycle analogous to Earth's water cycle. And Cassini's discoveries were not limited to Titan. It was Cassini that first spotted the spectacular plumes erupting from the south pole of Enceladus, flying directly through them to sample their composition, and providing the first concrete evidence for the hidden subsurface ocean that makes this tiny moon such a compelling target in the search for life. It was Cassini that finally explained the mystery of Iapetus's two-toned surface, confirming the role of the dark dust from the Phoebe ring. It was Cassini that discovered several new tiny moons and provided the definitive evidence that the rings are a young, dynamic, and actively evolving system. The mission was a relentless engine of discovery, its 13-year-long presence in the Saturn system allowing scientists to observe long-term changes, to watch the seasons slowly shift, and to witness dynamic events like the eruption of the Great White Spot of 2010 in stunning detail. The legacy of these 4 robotic explorers, from the pioneering flight of Pioneer 11 to the grand orbital tour of Cassini, is a testament to human ingenuity and our unyielding curiosity. But the story of our engagement with Saturn is not over. The discoveries made by Cassini, particularly at Titan and Enceladus, have opened up tantalizing new questions and have laid the groundwork for the next generation of missions. On the horizon is NASA's Dragonfly mission, an audacious and innovative concept that aims to send a robotic, nuclear-powered quadcopter to the surface of Titan. Scheduled to launch in 2028 and arrive at the giant moon in 2034, Dragonfly will be a mobile aerial explorer. It will be capable of flying from one location to another, hopping across the Titanian landscape to sample a wide variety of materials and environments. Its goal is to study prebiotic chemistry, to investigate the complex organic soup that exists on Titan's surface and in its atmosphere, and to search for any signs that this world, so rich in the building blocks of life, may have taken the next step. It is a mission born directly from the legacy of Cassini and Huygens, a bold leap into the future of planetary exploration, promising to unlock even more of the secrets of this captivating and mysterious corner of our solar system. This relentless scientific inquiry has not only revealed what Saturn is, but has also begun to unravel the subtle and powerful ways in which it functions. We now understand that Saturn possesses a powerful magnetic field, a vast, invisible bubble of magnetism that surrounds the planet and extends for millions of kilometers into space. This magnetosphere, as it is called, is generated deep within the planet's interior, a direct consequence of the planet's rapid rotation and the presence of that vast, churning ocean of metallic hydrogen we spoke of earlier. The motion of this electrically conductive fluid acts like a giant planetary scale dynamo, creating a magnetic field that, at the cloud tops, is some 578 times more powerful than Earth's. This magnetic field is not just a scientific curiosity. It is a powerful and dynamic force that shapes the entire Saturnian system. It traps charged particles from the solar wind and from the planet's own atmosphere, creating intense radiation belts. It funnels these particles toward the poles, creating the spectacular auroras. And it interacts with the rings and the moons in complex and fascinating ways, playing a crucial role in phenomena like the ring rain that is causing the rings to slowly disappear. One of the most peculiar and enduring mysteries related to this magnetic field is its almost perfect symmetry. Saturn's magnetic field is unique among all the planets in our solar system, in that it is almost perfectly aligned with the planet's rotational axis. On Earth, Jupiter, and other planets, the magnetic axis is significantly tilted relative to the rotational axis, which is what causes our magnetic poles to wander. But on Saturn, the tilt is almost non-existent, less than 0.007 degrees, a near-perfect alignment that challenges our fundamental theories of how planetary dynamos work. According to our best models, some degree of tilt is necessary to sustain the dynamo action. The fact that Saturn has a powerful magnetic field with almost no tilt is a major puzzle, a conundrum that suggests there are still fundamental aspects of planetary interiors and magnetic field generation that we do not yet fully understand. This perfectly aligned field is a silent testament to the deep, hidden processes churning away in the heart of the giant, a mystery that awaits future generations of explorers and theorists to solve. And this internal engine is so powerful that it causes Saturn to radiate more energy into space than it receives from the distant sun, a phenomenon that speaks to a planet that is still, in a very real sense, alive and evolving. The excess energy is a combination of the residual heat left over from its initial formation 4.5 billion years ago, and a strange, ongoing process occurring deep within its interior. This process is a kind of planetary scale differentiation, a slow, gentle rain of helium falling through the liquid hydrogen in its interior, a phenomenon known as the Kelvin-Helmholtz mechanism. As the helium droplets condense in the upper layers and fall inward, the friction they generate as they move through the denser hydrogen releases heat. This slow, gravitational settling is an ongoing source of energy, a process that has been gently warming the planet from the inside out for billions of years. And it is this internal furnace that helps to drive the planet's extreme winds and dynamic weather systems. Woven into this complex tapestry of rings, moons, and magnetic fields is another of Saturn's great unsolved mysteries, the enigmatic spokes of the Bee Ring. These features, first discovered by the Voyager spacecraft, are faint, dark, or sometimes bright, radial markings that stretch across the broad Bee Ring, perpendicular to the direction of orbit. They look like the spokes of a giant, ethereal wheel. The most baffling thing about them is their behavior. They can form and disappear in a matter of hours, and they rotate with the planet's magnetic field, not with the orbital speed of the ring particles themselves. This latter observation is the crucial clue, suggesting that they are not a gravitational phenomenon, but an electromagnetic one. The leading theory is that these spokes are composed of electrically charged sheets of microscopic, dust-sized particles that have been levitated out of the main ring plane by electrostatic forces. This levitation may be triggered by impacts of micrometeoroids on the rings, or by bolts of lightning from the planet's atmosphere that create beams of electrons, which then strike the rings. These charged dust particles are then swept along by Saturn's rotating magnetic field, creating the fleeting, spoke-like features we see. The Cassini spacecraft was able to observe the spokes again as Saturn's seasons changed, confirming their ephemeral nature and their connection to the planet's magnetic field. But the precise mechanism of their formation remains a subject of active debate, another beautiful puzzle in this endlessly fascinating system. This ephemeral nature, this constant dance of creation and dissolution that defines the spokes, is a microcosm of the planet itself, a world of slow, subtle, but profound transformations. Even the color of Saturn's vast atmosphere is not static, but is subject to change with the stately procession of its long seasons. As the planet journeys on its 29.4-year orbit around the Sun, its significant axial tilt exposes first one hemisphere and then the other to more direct solar radiation. This seasonal change in sunlight, particularly in the ultraviolet spectrum, has a direct and visible effect on the chemistry of the upper atmosphere. The increased energy from the sun during a hemisphere's summer appears to drive the production of more photochemical hazes, a kind of planetary smog, which can lend the entire hemisphere a deeper, more golden or yellowish hue. Conversely, during the winter, with less solar energy, the atmosphere can clear slightly, appearing paler and more muted. These are not rapid, dramatic shifts, but a slow, planet-wide blush that unfolds over the course of years, a subtle, seasonal rhythm playing out on a canvas thousands of times larger than the Earth. The Cassini mission, with its 13-year vigil, was uniquely positioned to observe one of these grand seasonal transitions, watching as the northern hemisphere slowly emerged from its long winter darkness and transitioned into spring, its colors slowly deepening in the returning light. But Saturn's influence extends far beyond the subtle chemistry of its own atmosphere. Its true power is written across the very architecture of the solar system. The planet is a gravitational behemoth, a colossal shepherd responsible for organizing and controlling vast populations of asteroids and comets. Its immense gravitational field carves out zones of stability and chaos, corralling small bodies into specific orbital paths and mercilessly ejecting others from the system entirely. This shepherding influence is most evident in the populations of small bodies that share orbits with the planets, their paths dictated by the stable gravitational points created by the Sun and the gas giants. Saturn, like Jupiter, helps to maintain these delicate orbital arrangements, its presence a constant, shaping force in the lives of countless smaller worlds. Yet, this gravitational power is not always gentle. Saturn's influence can also be a profound source of disruption. Its gravity can perturb the trajectory of a passing comet or asteroid, deflecting it from a stable, distant orbit and sending it hurtling toward the inner solar system. Many of the comets that have graced our skies, and many of the asteroids that pose a potential threat to our world, were likely set on their current paths by a gravitational nudge from Saturn or its larger sibling, Jupiter. The planet acts as both a gatekeeper and a rogue agent, a cosmic slingshot that can, with a subtle tug, rewrite the destiny of a smaller object, with potentially profound consequences for planets like our own. This role as a planetary architect was never more dramatic than in the chaotic early history of our solar system. The serene, orderly clockwork of the planets we see today belies a violent and tumultuous youth, and it is now widely believed that Saturn's formation and subsequent migration played a crucial and destructive role in this ancient drama. According to our leading models, the giant planets, including Saturn, likely formed much closer together and closer to the Sun than they are today. Over hundreds of millions of years, they slowly began to shift their orbits, a grand planetary migration driven by gravitational interactions with the vast disk of planetesimals, the leftover debris from the solar system's formation. During this epoch, Saturn's gravitational relationship with Jupiter was the key driver of events. At a certain point, the two giants entered a powerful orbital resonance, a state where their orbits became gravitationally synchronized, allowing their combined influence to grow enormously. This powerful resonance destabilized the entire outer solar system. In this grand upheaval, Saturn and Jupiter may well have been responsible for hurling the other two giant planets, Neptune and Uranus, into their current, far more distant orbits. This was a planetary game of billiards on a cosmic scale, a violent rearrangement that flung the ice giants outward, scattering the primordial disk of comets and asteroids, and unleashing a devastating barrage of impacts upon the inner planets, an event known as the Late Heavy Bombardment. Saturn, the serene, ringed beauty we see today, was once a primary agent of chaos, a world shifter whose gravitational signature is embedded in the very positions of the planets and the cratered faces of the moons. And just as Saturn's past was one of dramatic change, so too is its future. The planet's most iconic feature, the very symbol of its celestial majesty, is slowly wasting away. The rings are disappearing, their substance draining away in a constant, imperceptible shower onto the planet below. This process, confirmed by the Cassini spacecraft, is a complex interaction between the rings, the planet's magnetic field, and the harsh environment of space. Micrometeoroid impacts and bombardment by solar ultraviolet radiation constantly knock water molecules off the surfaces of the ice particles in the rings and give them a slight electrical charge. Once charged, these particles are no longer solely governed by gravity. They can now be captured by Saturn's powerful magnetic field, which sweeps through the ring plane. This field then funnels the captured water ions along its invisible lines of force, guiding them on a one-way journey down into the planet's upper atmosphere. This is the ring rain, a perpetual planetary-scale influx of water that is slowly but surely depleting the rings of their mass. The sheer volume of this rain is staggering. By some estimates, it is draining enough water from the rings to fill an Olympic-sized swimming pool every 30 minutes. This influx of water from the rings has a measurable effect, altering the chemistry and temperature of the regions of Saturn's atmosphere into which it falls, providing the very evidence that allowed scientists to confirm this process is happening. The glorious age of the rings is a temporary one, a fleeting cosmic spectacle destined to end. The immense gravity that drives this ring rain, the same force that allowed Saturn to reshape the solar system, is difficult to escape. To break free from Saturn's gravitational grasp, a spacecraft must achieve a staggering velocity, a speed known as the escape velocity. For Saturn, this speed is nearly 36 kilometers per second, which is approximately 22 miles per second. This is more than 3 times the escape velocity of Earth, a testament to the sheer depth of the gravitational well created by the planet's immense mass. Any rocket launched from the cloud tops of Saturn would need to reach this incredible speed to break free and journey into interplanetary space. This gravitational dominance is not just a local phenomenon. It is a defining characteristic of the outer solar system. When we consider the distribution of mass among the planets, the scale of Saturn's influence becomes even clearer. Saturn and Jupiter together are the undisputed titans of our planetary system. These two gas giants collectively account for a staggering 92% of the total planetary mass in our solar system. All the other 6 planets, the rocky inner worlds of Mercury, Venus, Earth, and Mars, as well as the distant ice giants Uranus and Neptune, combined, make up a mere 8% of the total. This simple fact underscores why these 2 worlds were the primary architects of the solar system's history. Their combined gravitational power is the overwhelming force that has shaped the orbits, positions, and even the very existence of the smaller bodies around them. And this immense mass, this deep gravity, is the ultimate source of the incredible energy we see playing out on the planet's surface. This energy is most dramatically expressed in the planet's powerful winds. In the equatorial zone, the atmosphere is dominated by a powerful eastward flow, a vast, planet-encircling jet stream with a maximum velocity of about 470 meters per second. This translates to an almost unbelievable 1,692 kilometers per hour, or about 1,051 miles per hour. A constant, furious river of gas powered by the deep internal heat of this massive, dynamic world. This furious river of gas, the great equatorial jet, is but the most prominent feature of a remarkably ordered and symmetrical global wind system. The zonal flows in Saturn's atmosphere, the alternating bands of east and west moving jet streams, are organized with an almost geometric precision, displaying a striking degree of symmetry about the planet's equator. This is in marked contrast to Jupiter, where the wind patterns are more chaotic and asymmetric. On Saturn, for every jet stream flowing in one direction at a certain latitude in the northern hemisphere, there is a nearly identical mirror image jet stream flowing at the same latitude in the southern hemisphere. This profound symmetry suggests that the atmospheric flows are deeply connected to the planet's interior. Their patterns dictated not by the random, chaotic weather of the upper cloud layers, but by the fundamental physics of the deep, rotating shell of metallic hydrogen. The planet's weather, in a very real sense, is an expression of its deep internal structure, a structure that is itself profoundly symmetrical. This underlying order, however, does not preclude the existence of violent, localized storms. Indeed, as we journey away from the equator and toward the poles, the orderly, banded flow gives way to a more turbulent and chaotic regime. Within about 11 degrees of latitude of both the North and South poles, the atmosphere is dominated by strong, hurricane-like cyclonic vortices. These are not the gentle, anticyclonic ovals found at lower latitudes, but powerful, low-pressure systems that spin in the same direction as the planet's rotation, akin to the cyclones and hurricanes we experience on Earth. The most prominent of these are the giant, permanent polar vortices we encountered earlier, the bizarre northern hexagon and the southern polar hurricane, each a unique and awe-inspiring testament to the extreme forces at play in these high-latitude regions. This world of extreme forces and symmetrical beauty is, for all its majesty, a very distant neighbor. The vast gulf of space that separates us from Saturn is a testament to the sheer scale of our solar system. At its closest approach to Earth, a point in its orbit known as opposition, when Earth lies directly between Saturn and the Sun, the ringed planet is still about 1.2 billion kilometers, or roughly 746 million miles, away from us. This immense distance is why, for all of human history before the invention of the telescope, it remained nothing more than a star-like point of light. Even in our modern age of powerful rocketry, the journey to Saturn is a long and arduous one, taking robotic spacecraft like Cassini a full 7 years to complete. This distance also dictates how we are able to view the planet. From our vantage point on Earth, Saturn always appears nearly fully illuminated by the Sun. We are forever looking at its day side, much as we almost always see a full or nearly full moon. The geometry of our inner solar system orbit means we can never see a crescent Saturn or view its magnificent rings from the shadowy night side of the planet. These unique perspectives, the dramatic side-lit views that cast the rings in sharp relief, or the breathtaking backlit images where the rings seem to glow with an ethereal forward scattered light, are reserved exclusively for the robotic eyes of our deep space probes. It is only through these emissaries that we can witness the planet in its full, three-dimensional glory, to see the sun rise and set over its cloud tops, and to appreciate the delicate, almost translucent nature of its rings when illuminated from behind. This distant world is also a world of profound and unrelenting cold. The average temperature at the level in Saturn's atmosphere, where the pressure is equal to the sea level pressure on Earth, is a frigid minus 138 degrees Celsius, which is approximately minus 218 degrees Fahrenheit. This is a cold so intense that it would instantly freeze any terrestrial life form solid. This deep freeze is a direct consequence of the planet's vast distance from the Sun. At its orbital position, Saturn receives only about 1% of the intensity of sunlight that bathes our own world. The Sun, which dominates our sky and warms our planet, is reduced to a small, brilliant, but distant star in the Saturnian sky, its power to heat the atmosphere greatly diminished. This lack of external heating is what allows the planet's own internal furnace to become the dominant driver of its climate, creating a world where the weather is powered from within, rather than from above. This internal heat engine, combined with the planet's rapid rotation, is what gives birth to some of the fastest and most powerful winds in our entire solar system. A paradox of a cold world with a furiously active atmosphere. The cold, the immense pressure, the lack of a solid surface, and the non-breathable composition of the atmosphere all combine to make Saturn a place where human life, as we know it, is an impossibility. There is no ground to stand on, no air to breathe, no shelter from the crushing pressures and the extreme temperatures. It is a world designed for giants, not for us. To visit Saturn is a journey that must be undertaken by our robotic proxies, our durable, unfeeling extensions of our own senses. For it is a realm that is, and will likely forever remain, fundamentally inhospitable to human explorers. And so we are left to gaze from afar, to appreciate this magnificent world through the lenses of our telescopes and the data streams from our spacecraft. In this appreciation, Saturn has earned a well-deserved and evocative nickname. It is often called the Jewel of the Solar System, a title that perfectly captures the sense of wonder and beauty it inspires. Its perfect, pale golden sphere, adorned with the most exquisite and intricate system of rings imaginable, gives it the appearance of a celestial treasure, a priceless ornament set against the black velvet of deep space. It is a world that has captivated the human imagination for centuries, a symbol of cosmic elegance and mystery. From the ancient shepherds who tracked its slow path across the sky, to Galileo, who first glimpsed its strange form, to the modern scientists who pilot robotic explorers through its rings and moons, Saturn has been a source of profound inspiration and a catalyst for discovery. It is a world that reminds us that the universe is not just a place of empty voids and violent explosions, but also a realm of breathtaking beauty and sublime geometric order. Its story is a grand narrative of cosmic forces, of gravitational dances, of ephemeral rings and hidden oceans, a story that we have only just begun to read. Each new discovery, each new image sent back across the vastness of space only deepens our appreciation for this celestial jewel and reinforces its status as one of the true wonders of our solar system. The 100 facts we have explored are but a snapshot of our current knowledge, a single chapter in an ever-unfolding story, a story of a world that will continue to surprise, to mystify, and to inspire us for as long as we continue to look up and wonder. And so, our long voyage through the Saturnian system draws to a close. That serene, golden point of light, the ancient god of time and harvest, has been transformed by our relentless curiosity into a universe in miniature. It is no longer a simple object, but a complex and dynamic system of rings that are born from cataclysm and are slowly reigning into oblivion, and of moons that hold the promise of hidden oceans and the chemical precursors to life. Through the silent emissaries, we have sent on journeys of years and decades. We have touched its alien shores, tasted the spray of its icy geysers, and mapped the shores of its methane seas. Their legacy, a treasure of data and images sent back across the vastness of space, has painted a portrait of a world more intricate, more beautiful, and more surprising than our ancestors could ever have imagined. Saturn is no longer merely a planet. It is a lesson in cosmic mechanics, a laboratory for exotic chemistry, a cautionary tale of ephemeral beauty, and a beacon of hope in the search for life beyond our own world. The next time you find yourself under a clear, dark sky and spot that steady, yellowish star making its slow, patient journey across the heavens, perhaps it will appear as something more, no longer just a distant light, but a destination, a place we have visited, a world we have come to know, and a reminder of the infinite, intricate wonders that await us in the great, silent story of the cosmos.